Today we will discuss about trigonometry. So first, what is trigonometry? Trigonometry, it is the study of relationship between lengths and angles of the triangle. The word trigonometry derived from the Greek word trigonometria, meaning triangle measure. Trigonometry has its functions such as sine, cosine, and tangent that are used in computation in trigonometry. But the main particular trigonometry function that we will focus is sine and cosine.
When it comes to the dark arts, I believe in practical approach. But first, can you tell me how many unforgivable curses they are? You're correct. They are 3 unforgivable curses. The minister says, "You're too young to see what these curses do." I say different. You need to know what they're up against you. You need to be prepared to solve the value of A, B, C, and D to graph a sine. So, for the first curse, it's called the imperious curse. Kobocho. Imperio. Wow, magic. So, just always remember that we have a standard form that is y is equals to a sine b quantity x minus c plus d. So for our given equation, or for our example, it is y is equals to 1/4 sine 2 quantity x minus 2 pi plus 3. So for our given, we can identify what is the value of a, b, c, and d. The value of a is going to be positive 1/4. The value of b is going to be this number, which is positive 2. And the value of c is negative 2 pi. Why negative 2 pi? Because in the book, that would say that the value of c is going to be 2 pi. But what our teacher told us is the pattern of the phase shift is negative c. That's the reason why there is no difference between the two of them. Now, for the last value, the value of d is going to be positive 3. Now, for the next curse, it's called the Cruciatus curse. Crucio! Wow, magic! Now, in order to find the amplitude, we are going to apply the formula A is equals to the absolute value of A. And in order to find the period, we are going to use this formula, which is P is equals to 2 pi over B. Next is the phase shift, which is PS is equals to negative C. The last one is the vertical shift, which is BS is equals to D. Now let's solve this equation. Y is equals to 1/4 sine 2 quantity x minus 2 pi plus 3. Now in our equation, we all know that our value of A is 1/4. So the amplitude, to find the amplitude, we're going to use this formula, the absolute value of A. Now instead of writing A, we're going to write 1/4. So the absolute value of 1/4 is equals to 1/4. So the value of our amplitude is equals to 1/4. Now for the period is equals to 2 pi over B. Now we all know that the value for B is equals to 2. Now we're going to substitute the number 2 to the formula, which is 2 pi is equals to 2. Then simplify the equation, then the answer would be is equals to pi. Period is equals to pi. Next is the phase shift. In order to find the phase shift, we're going to substitute our c, which is negative 2 pi, to this equation. So it will be positive 2 pi. Since it is positive, our phase shift is 2 pi units to the right. If our given phase shift is negative, therefore it will be 2 pi units to the left. Since that our phase shift is positive, therefore our phase shift is 2 pi units to the right. For our vertical shift, our d, our value of our d is 3, which means that therefore that the movement of our vertical shift is going to be 3 units upward because it is positive. It is 3 units upward for our given function y is equals 1/4 sine 2 quantity x minus 2 pi plus 3. And that's it. That's how we solve for our ABCD and amplitude, period, phase shift, and vertical shift. And now,
Good day, students. I am Professor Remus Lupit. Now, we are gonna talk about the domain, the range, and the graph of sine function. First, let me explain what the domain is. The domain of a function f of x is the set of all values for which the function is defined. The domain is the set of all possible x values which will make the function work and will output real y values. This is also called replacement set. Next is the range. The range of the function is the set of all values that f takes. The range of a function is the complete set of all possible resulting values of the dependent variable after we have substituted the domain. For the sine function, this is the domain and this is the range. Negative amplitude plus d and positive amplitude plus d. Now for the domain, it depends. For the previous example, this is the domain. The domain is all real numbers, but let's be clear. Not all cases would have all real numbers as a domain since there might be restriction depending on the given equation. For the range, it would be 11 over 4, 13 over 4 since negative 1/4 plus 3 is 11 over 4 and positive 1/4 plus 3 is 13 over 4. Now, let's proceed to the graph. This table of patterns came from our headmaster. He spent days and nights just to make this pattern for the students to be at ease. In getting x-intercept, these are the patterns. 0 plus or minus phase shift. Now, the operation that we will use on this term depends on the sign of the phase shift. If it is positive, then we would use addition, and if it is negative, then subtraction. Let's proceed to the next. P over 4 plus or minus phase shift, P over 2 plus or minus phase shift, 3P over 4 plus or minus phase shift, and period plus or minus phase shift. In getting y-intercept, these are the patterns. 0 plus d, positive or negative a plus d, 0 plus d, negative or positive a plus d, and 0 plus d. If the value of a is positive, the first representation would be positive and the second should be in negative, and vice versa. Now let's try to get the intercepts of the previous example. Y is equal to 1/4 sine 2 times the quantity of x minus 2 pi plus 3. We would substitute the values of phase shift, period, a and d to get these values. For the x-intercept, 2 pi, 9 pi over 4, 5 pi over 2, 11 pi over 4, and 3 pi. For the y-intercept, the values are 3, 13 over 4, 3, 11 over 4, and 3. Now, let's examine the graph. As you can see, the fraction is transformed into its decimal form to precisely point the exact location.
Now, we are going to be taking a look at the sample equation of the sine function. We have y is equals to 5 minus 4 sine quantity 1/2 x plus pi. And we all know that the first step in solving any sine function is to get its standard form. Now, the standard form of this equation is going to be y is equals to negative 4 sine times 1/2 quantity x plus 2 pi plus 5. Now, the a value is going to be negative 4, the b value is going to be 1/2, the c value is going to be 2 pi, and the d value is going to be 5. Now, to get the amplitude, we simply need to get the absolute value of the a value. So the absolute value of negative 4 is going to be positive 4. To get the period, we need to divide 2 pi all over the value of b, and 2 pi divided by 1/2 is going to equal to 4 pi. To get the phase shift, we simply need to get the negative c, and the c value is 2 pi, so we only need to add a negative sign in front, so we get negative 2 pi units to the left. For the vertical shift, we have 5 units upward. For the domain, it's going to be all real numbers. Why? Because in every sine and cosine function, the domain is always going to be all real numbers. And the range for this equation is going to be 1 and 9 in closed brackets. And now the next step is going to be identifying the x and y values for us to plot the graph. So, as we seen in the table of formulas earlier, we just need to substitute all of our values. Now we will get negative 2 pi, negative pi, and 0. Now up until this point, we see a pattern. And from negative 2 pi to 0, we've only been adding 1 pi. So negative 2 pi plus positive pi is going to be negative pi, and negative pi plus positive pi is going to be 0. And if we add positive pi to 0, it's going to be positive pi, and 1 pi plus 1 pi is going to be 2 pi. And substituting the values in the formula that we seen earlier, we get 5, 1, 5, 9, and 5. Now we can plot these values and the graph will look like this. And that's all.
The standard form of cosine. Y equals to 3 cos x plus 4 pi plus 2. Let's identify the value of a, b, c, and d. The value of a is 3, the value of b is 1 since it's divisible by 1 in cos, then the value of c is equals to 4 pi, and the value of d is equals to 2. Then after identifying the value of a, b, c, and d, we're going to identify the amplitude, period, phase shift, and vertical shift. For amplitude, we have absolute value of a. A is equal to 3, therefore the absolute value of a is equals to 3. For period, we have 2 pi over b. Our b is equals to 1. So instead of writing b, we're going to write 2 pi over 1. So our p is equals to 2 pi. For phase shift, we're just going to substitute negative c to 3. Then equal negative 4 pi. Since it's negative, it's going to be 4 pi units to the left. If it's positive, it will be to the right. For vertical shift, we're just going to substitute d to 2. Since d is equals to 2, then equal to positive 2. Since it's positive, it's going to be 2 units upward. If it's negative, it will become upward. After identifying those, we're going to identify the domain and the range. For domain, since there is no restriction, it will be all set of real numbers. For range, we're going to use this. We're just going to substitute negative a to negative 3 plus d to positive 2. And positive a to negative to positive 2. Then negative 3 plus 2 is equals to negative 1. Then positive 3 plus 2 is equals to positive 5. After identifying those values, we're going to use these tables. We just need to substitute these phase shifts and A and D to get these answers. Negative 4 pi, negative 7 pi over 2, negative 3 pi, negative pi pi over 2, negative 2 pi. Then 5, 2, 1, 2, 5. This is the graph. As you can see, 4 pi over 5. Then negative 7 pi over 2 to over 2. Then negative 3 pi to negative 1. Negative 2 pi over 5. Negative 5 pi over 2 to 2. That's all for cosine.
So hello students. So for this one, we have here the sample equation for the cosine. So here is our equation. So y is equals to negative 2 cosine quantity 1/3 x minus pi plus 1. The first thing that we're going to do is to factor out the 1/3. Then we will be having y is equals to negative 2 cosine 1/3 quantity x minus 3 pi plus 1. So let's identify the values of a, b, c, and d. So we have here a is equals to negative 2, b is equals to 1/3, c is equals to negative 3, and d is equals to positive 1. Next is the amplitude, which is the absolute value of a, which is 2. So period is equals to 2 pi over b. So 2 pi over 1/3 is simply 2 pi times 3, which is 6 pi. So the phase shift is negative c, since our c is negative 3 pi. So our phase shift will be 3 pi. Or the graph will move 3 pi units to the right. Next is the vertical shift, d is equals to 1. So our graph will move 1 unit upward. Next is domain, all real numbers, and the range is negative 1 and 3. So before we graph, let's first identify the values of x and y. So here, to find the value of x, we have 0 plus phase shift. So 0 plus 3 pi is 3 pi. The next is period over 4 over I plus phase shift is equals to 6 pi over 2, which is 3 pi over 2 plus 3 pi is equals to 9 pi over 2. Next is 6 pi. So we can see here that we're just only adding 3 pi over 2. So 6 pi plus 3 pi over 2 is equals to 15 pi over 2. Then 15 pi over 2 plus 3 pi over 2 is equals to 18 pi over 2 or 9 pi. So for the value of y, since we have here the value of negative as our a, so negative 2 plus 1b is negative 1. Then next is 0 plus t, which is positive 1. Then next is positive 2, or positive a plus 1 is 3. Then 0 plus d is 1. And then let's all copy this, negative 1. So for the graph of the equation, y is equals to negative 2 cosine 1/3 quantity x minus 3 pi plus 1. Here is the coordinates. So we have negative 3 pi and 1, negative positive 9 pi over 2 and 1, 6 pi and 3, 15 pi over 2 and 1, and 9 pi and negative 1. So let's proceed for the real-life application of the graph of sine and cosine function. So the graph of sine and cosine function can be applied in music industry as it allows us to measure the sound quality that we are producing with our voice together with the various instruments that we are using in making and creating music. So let's say for example amplitude. So the amplitude tells us or determines how loud the sound is. So basically the graph of sine and cosine helps the people, particularly the musicians, to identify the most appropriate sound quality in a specific type of music that they are playing. So sound waves travel in a repeating wave pattern which can be represented by sine and cosine function. And this allows researchers to study these waves. So graphical representation of music allows computer to create and understand sound, as it also allows sound engineers to visualize sound waves so that they can and adjust the volume and pitch together with the other elements to create a desired sound for the human ears to receive. So these examples prove that the graph of sine and cosine is an application for real life. So I have here a sample journal article where the graph of sines helps a researcher to prove their hypothesis, to come up with an accurate results, to have a great conclusion toward a specific problem. So these are just some of the examples which prove that the sine and cosine graph is an application in real world, as it helps humans in different ways.